All right, hi guys, it's Mrs. Power again. I heard that my last video had all kinds of lagginess to it and probably not great video quality, so we're going to try it again today. I still think it'd be kind of fun to see both Miss Mitchell and I give different lessons. So let's get started. So we're mostly reviewing geometry, algebra 2 stuff about right triangle trig. So the first thing that we're going to talk about is the idea of the Pythagorean theorem. So Pythagorean theorem, remember, is a way to find any of the sides of a right triangle, and that would be using a squared plus b squared equals c squared, and that's always assuming that the hypotenuse is c squared, and that the two legs can be named either, let's make that c instead. The hypotenuse is labeled c, and then the two legs, you can name them either way you want. Either one can be a and either one can be b. All right, so the other thing we have working on here is remembering that we're going to be using that phrase SOHCAHTOA, and I'm going to write it vertically here. SOHCAHTOA. And the reason I do it vertically is because then we can actually put the fraction in place so that you actually know what goes with what. So remember that S stands for sine, C stands for cosine, and T stands for tangent. And so if we wanted to write sine of theta, we would want to say that it is O over H. And of course, that's going to depend on where we're standing on the triangle. So we never stand at the right angle. We're always going to be standing at one of the acute angles on the side. And so I draw my little stick figure dude there. And if I'm standing right here, my feet are always standing on two different parts. One foot is always on the hypotenuse. The other foot is always on the adjacent side. And then the remaining side, if I travel all the way across, is the opposite side. So if they want me to do sine from where I'm standing, and we're using that symbol theta to be the angle of where I'm standing, then I would want to give them the two sides O over H. So if I'm using the darker letters, that would be O over H would be A over C. Okay, and then cosine would be A over H. And if we're looking at our picture and where I'm standing, then A over H would be B over C. And lastly, tangent is going to be O over A. And again, I'm getting them from looking over here and reminding myself that if it's a sine problem, I'm going to be doing O over H. If it's a cosine problem, I'm going to be giving the fraction A over H. And if I'm doing a tangent problem, I'm going to give them O over A. So for tangent, we are doing O over A, and that is going to be A over B. There's another reason why we always write them in this order is if you notice that sine is A over C, cosine is B over C, and if you notice, tangent ends up being both of those in order over each other. So that's another easy way to remember where everything goes. Okay, so cosecant, these are called reciprocal functions, which just means that we flip them over. So I'm going to write up here, reciprocal functions. Okay, so these are the reciprocal functions, it's these up here. So cosecant is going to be the reciprocal of sine. So that means it's going to be H over O. And in our picture, that is going to be C over A. Okay, and the next one is going to be H over A and then A over O. And then if we put them based on the picture, we're going to have H over A is going to be C over B, and then tangent is going to be flipped upside down, so it's going to be B over A. Okay, so you should be able to know which ones go with which. So how do I know that the reciprocal of sine is cosecant? Well, notice that sine starts with an S and cosecant starts with a C. Cosine starts with a C and its reciprocal starts with an S. So there's that letter flip. So as long as you can remember these three are the main ones, then getting to their reciprocals is just a matter of switching those first letters around. And then tangent is the easy one because its reciprocal function is just cotangent. All right, so let's see if we can use some of this. So it says find the 6 trig functions of theta. So first thing I'm going to do is go draw my little stick figure dude right here. I'm going to label all my sides. So if I'm standing at theta, one foot is going to be on the hypotenuse, 1 foot is going to be on the adjacent side, and it's the opposite side that's all the way on the other side. All right, so what I notice is that 2 of those sides are labeled. O and A, we have numbers 8 and 6. Hypotenuse does not. So the first thing we're going to do is we're going to use Pythagorean theorem to solve for this. So the 2 legs in either order. So I'm going to do 8 squared plus 6 squared equals c squared. That's going to give me 64 plus 36 equals c squared. That means c squared is 100 and c must be 10. So this is a 10. So we have 6, 8, and 10 as our 3 sides. All right, so next step is I'm going to move over to this side and I'm going to write down sine at theta is, cosine at theta is, tangent at theta is, and then we're going to go and fill in each one of those based on what we have. So if I'm standing here and they say do sine of theta, they want me to write 6 over 10, and then I'm going to reduce that and make it 3 over 5. Cosine is going to be a over h, that's 8 over 10. That's going to reduce down to 4 over 5. And tangent is going to be 6 over 8, which is going to reduce down to 3 over 4. So they said they did want 6, so the other 6 are going to be the reciprocals. So remember, if it starts with sine, the reciprocal is going to start with c. So this is cosecant of theta. This starts with a c, so I want the weird one that starts with an s, so that's secant of theta. And then tangent is going to be cotangent of theta. All right, and then for those, I can look at the picture again and just do each one of those sides over each other, or I could just cheat and take my simplified fraction and just flip it upside down. So I'm all for the cheating the faster way. So 5 over 3 for that one, 5 over 4 for this one, 4 over 3 for this one. And we've got all 6 functions, the original basic 3 and their reciprocals. All right, next thing we want to look at is there are 2 very special triangles. The first one is a 45-45. Now the square means 90, so if this one's 45, that means the other one is 45. The other thing I know about 45-45 triangles is that opposite sides of opposite angles should be the same amount. So if opposite this 45 is a 1, then opposite this 45 is another 1. And why is this one such a special one? Well, it's because it comes from one of our most special polygons, which is a square. So if you take a square and you draw in a diagonal, you get a 45-45. So that's one of the main reasons that we like this one and we study this one. So how am I going to figure out what the third side is? Well, Pythagorean theorem again. So I'm going to have 1 squared plus 1 squared equals c squared. That's going to be 1 plus 1 equals c squared. That's going to be c squared equals 2, or c is square root of 2. So now I know this one is square root of 2. All right, so they said find all the missing sides and all the missing angles. We did that. We have 3 sides, we have 3 angles. Next is they want us to write all 6 trig functions. Okay, so we're going to decide where do we want to stand at. It's going to be the same picture no matter where I stand. So I'm going to use the original one that they had me stand at, which is this one. So if I'm standing here, my 2 feet should be on hypotenuse and adjacent, and this one's opposite. So here we go again with sine of theta. Actually, it's not even sine of theta. I actually know what it is. It's sine of 45. Cosine of 45, tangent of 45. Okay, so what are each one of those? So sine is going to be O over H. So that's going to be 1 over square root of 2. And remember, we don't like square roots on the bottom. So if I fix that, it becomes square root of 2 over 2. Cosine is going to be a over h, so it's going to look exactly the same way. It's going to still turn out to be square root of 2 over 2. Tangent is O over a. O over a is going to be 1 over 1. That's a 1. Okay, and then I'm going to go ahead and cheat for the reciprocal function. So if it starts with a s, I'm going to go for cosecant of 45. If it starts with a c, I'm going to go for secant of 45. And if it starts with a t, we're going to go with cotangent of 45. Now I'm going to just go ahead and flip each one of these fractions, but think about this for a second. If I try to flip this fraction upside down, I'm going to have to fix it again because it's going to have a square root of 2 in the denominator. So much easier to go back to this original one because then I don't have to fix it. So it's just going to be square root of 2 over 1 or just square root of 2. This one, if I switch that one, it's also going to be just square root of 2. And 1 over 1, if you flip that one upside down, that's still a 1 over 1 as well. All right, so there we have all the missing sides. Later, we're going to talk about that they don't have to give you an awful lot of information on a 45-45. One, because I can always use that Pythagorean theorem to find any one of the sides if I'm missing some, because I know two sides are matching. But the other thing to keep in mind is you might have remembered long ago that there was a pattern that you were kind of supposed to remember, and that was if you always label the shortest side x, that would be this side. That would mean this side is also an x because it's also the shortest side. And then if you knew the shortest side to get over here to the square root of 2, it's always going to be x times square root of 2, meaning that I'm going to take the short side, and if I follow the arrow and I multiply by square root of 2, I'll get the hypotenuse. So that's kind of like a shortcut memorization trick. That also means if I go against the arrow, if I knew the hypotenuse, I could just find the sides by dividing by square root of 2 and go against the arrow. All right, so let's go to the next one. It's a 30, 60, 90 triangle. All right, so here's the deal with the 30, 60, 90. It also has a really special thing to it. That's why we study it, is if this side is 60 right here, then this side has to be a 30, right? Because we know it has to add up to 180, and if we already used up 90, it means the two acute angles have to add up to make 90. If I were to mirror this to make another triangle going this way, I would have a three-sided, obviously, triangle, three-sided, that is a 60, 60, and 60 degree. That means it's equal angular. That means it's equilateral. So the reason we study this one is because, again, it's cutting one of our famous polygons in half. And that's our most perfect three-sided triangle, the equilateral or equiangular. All right, so same deal here. We did find all the angles, but we haven't found all the sides yet. All right, so they told us this side is 1. See, now this one is tricky because I don't know what the other two sides are based on that 1. But if I know it comes from if I know it comes from an equilateral triangle, then I also know this little mirrored one is also a 1. That means that this entire bottom of the equilateral triangle is 2. That means this side, the hypotenuse of the triangle they gave me, also has to be 2. Now I could use Pythagorean theorem and figure out what that missing side is. So we're going to go do that. So in this left side triangle that was originally there, I have 1 squared plus b squared equals 2 squared, right? Because the hypotenuse is the 2. So this is going to turn into b squared equals 4 minus 1. B squared is 3. B is square root of 3. So I now know that the height of this triangle is square root of 3. All right, so now that I know the three sides, the three angles, I can go ahead and write my trig functions. So again, it's going to matter on where I'm standing. So since they originally gave me the 60, I'm going to do these as a 60-degree triangle. I'm going to stand right there. And if I do that, this is hypotenuse. One foot is always on hypotenuse. One side is always on adjacent. And then this radical 3 will be the opposite side. Okay, so then I'm going to go ahead and I'm going to do sine of 60, cosine of 60, tangent of 60. And if I do sine of 60, I'm doing O over H. So that is radical 3 over 2. Cool. If I do cosine, it's going to be 1 over 2. Also cool. And if I do tangent, it's going to be O over A. That is radical 3 over 1, or just radical 3. Okay. So next step is to go and do the reciprocals. So cosecant at 60, secant at 60, cotangent at 60. So this one, when I flip it upside down, right, I'm going to have to fix it with another square root of 3 over square root of 3. So I'm going to get 2 square root of 3 over 3. And for the secant one, if I just flip it over, I get 2. And the cotangent one, if I flip that over, I'm going to get 1 over square root of 3. I'm going to have to fix that one again, and I'm going to get square root of 3 over 3. Awesome. All right. So notice that cosine at 1/2 is, or cosine of 60 is based on me standing at the 60. What would have happened if I would have been standing up here at the 30 instead? Okay, so I'm going to just go draw another triangle real quick. Here's the 30, here's the 60. And if I would have been standing here, the measurements of the triangle don't change. This is still a 1, this is still a 2, this is still a square root of 3. right? But if I wanted to get that square root of 3 over 2 that they got at 60, I would have to do a over h. So isn't that kind of cool? That sine of 60 is going to give me the same answer as cosine at 30. Now, if you think about it, that kind of makes sense. If I stand one place, the opposite and the adjacent are going to flip, right? So instead of it being O over H, we get A over H if I flip to the other side. So the next page is all about that idea of how do you find ones that match each other, right? So for cofunctions, here's the really cool thing is cofunctions are not reciprocals, okay? They're just cofunctions. So cofunctions means if I go to the other angle, how do I know if I'm going to the other angle? I'm going to write down 90 minus theta, meaning whatever that angle is, I'm going to go 90 minus it to get to the other one, okay? So notice that sine and cosine, you get it? Cofunctions are going to be equal to each other if you do the other angle. So guess what? Tangent and cotangent match up if you switch to the other angle. Secant and cosecant are going to be the same fraction if you switch to the other angle, the other acute angle in the triangle, right? Over here we're going to do, starting at cosine, we just remove the co and we get sine. Cotangent, remove the co and you get tangent at 90 minus theta. And cosecant, just remove the co and you get secant at 90 minus theta. These are some of my favorite ones to do. There's not a lot of questions that they usually ask, but they might say, if they use the word cofunction, that's what they're looking for you to do, is to switch to the other angle and then readjust your O's and your A's so that you get the same fraction for the trig. Okay, so here's an example of things that they could ask you. So what's the cofunction with the same value? So that means the same fraction. So it's got a sine. I'm going to write cosine. And then the angle is going to be 90 minus 72. So that's going to be cosine of 18 should be exactly the same value if I were to do a triangle as sine of 72. Okay, so cosecant pi over 3. So that's in the other measurements of radians. So I have to go back and think about how do I do 90? So if I remember right, 180 degrees is the same thing as pi. That means 90 degrees is going to be the same thing as half a pi, or pi over 2. So I'm going to switch the function or the trig word first. So it's cosecant. I'm going to go to secant. And now I have to do 90 degrees, which is pi over 2, minus pi over 6. Okay, so now I got to do common denominators of 6's. This is going to be 3 pi minus 2 pi with a secant in front. And so if I subtract those, I'm going to get secant of 1 pi over 6. Okay, and then tangent, we're going to do the cofunction first, so that is cotangent. And then I'm going to subtract it from 90, which is pi over 2 minus pi over 12. Common denominator here is going to be a 12, so this is going to be 6 pi minus 1 pi, cotangent. And then if I subtract those, I'm going to get 5 pi over 12. Cool. All right. Last thing is finding missing sides or angles using your calculator. Okay, so first thing we're going to do is we're still going to go and we're still going to stand on the triangle, draw our little stick figure person right there, label our sides. Remember our two feet. 1 foot is on adjacent, 1 foot is on hypotenuse. That makes this the opposite side. All right, so if I'm using an angle, the main format for these are always going to be trig, whatever the trig word, that's sine, cosine, whatever, of the angle, that's the angle symbol, equals whatever one side is over another side. So I know the angle is 61. My job now is to figure out what two sides do I have, and they might be the one I'm solving for. So I have O and A. So what trig function uses O and A? So Katoa. All right, sorry about that. I had to step away for just a second. So we were in the middle of figuring out what to use for number 4, and we said since they gave us a label A, that's what they're asking us to find, and I have the side 1, right? So I have opposite and adjacent. So the trig function that works for that is tangent. So I'm going to first write down the equation. Tangent of 61 degrees equals A over 1. Those are the original numbers that were in the actual triangle. All right, next thing I want to do is I want to solve for the unknown. So that's the little a. So if there was a different number under there, I would just multiply it over to the other side and it would show up before the word tangent. All right, so now I have a equals tangent of 61 degrees. That's it. All right, so how do I do that in the calculator? Well, if you are going to be using your graphing calculator, the first thing you have to do is you need to go up near the top. So let's see, I'm going to go this way. And you will see over here, the second button over is a mode button. And you want to press that, like the third line down. You want to make sure it says degrees if you're doing trig on degrees. It's really trig where it really matters whether you're in radians or degrees. Okay, so I see that I'm in degrees, and then the way to get out of that is you press second quit or second mode to get back out to the main screen. So I'm just going to type in tangent 61 equals. And it just gives me the answer and I write it down. They didn't tell me how much to round to, so I'm just going to round to 1 decimal point. So I'm getting 1.8 for that missing side A. Okay, and that kind of makes sense because the other missing angle was definitely less than 60, and we already had a 1, so it should have been a little bit more than 1 since it was opposite a bigger angle. All right, let's try to go do the other one this time. So this time I'm going to stand up here by the 34 degree. And again, my 2 feet are on hypotenuse and adjacent, and opposite is over here. So this time I am looking at, sorry about that, let's bring me back. Where did I go? Where did I go? Hang on. It's like the world doesn't want me to finish these notes tonight. All right, so we're on number 5. So I want to look at, they gave me this side was 13. They gave me this side is A, so they must want me to find A. And I have 34 degrees. So from where I'm standing, I want to use the trig function that uses O and H. That's going to be sine. I'm going to write the equation. So I'm going to do sine when I'm at 34 degrees is A over 13. So this time I'm going to multiply both sides by 13. Notice I'm not multiplying the angle by 13. It's just the 13 that moves out to the front. And I'm going to grab my calculator and just type in 13 sine 34 and round to 1 decimal place, and I'm going to get 7.3. Okay. All right, last thing we've got to do is a couple word problems. So obviously most of these we're going to be writing a right angle somewhere. So just imagine that if they don't give you a picture, you're trying to find the right angle to draw in there. All right, so the first one, sighting the top of the building. That just means they're looking at the top of the building. A surveyor, that's a person who measures stuff, measured the angle of elevation to be 22. So remember, angle of elevation always starts from a horizontal, and if they say elevation, your other ray of your angle will be up, and if it says angle of depression, your angle would start at the horizontal and go down this way if it was a depression problem. So if they say angle of elevation, they're just saying from the horizontal up is 22 degrees. And they said there's a camera is 5 feet above the ground and 300 feet from the building. All right, so here is my building. Here is the ground, okay? And they are saying that this camera is somewhere 5 feet above the ground, okay? So that vertical distance is 5 feet. They're also saying that this camera has a, what degree? 22 degree angle of elevation. So that's going to be from the horizontal to there is 22 degrees. So this part is 22 degrees. All right. We have the 5 feet. Where does the 300 feet go? It says it is 300 feet from the building. Okay, so I am taking that to mean that the camera is 300 feet this way from the building, and they are asking me to find the building's height. So they're asking me to find this. Okay, well, I can see where my right triangle is. It's right here, and they're already trying to be tricky by giving me another parallel line, the ground and then that sight line that form my angle of elevation. So if the ground is 300 feet, then so is by the sight line, okay? So if I'm standing here, I have adjacent, and I'm looking for opposite. Okay, so that's a tangent. So I'm going to do tangent of 22 equals O over A. That's x over 300. Okay, if I solve for x, whoa, hello, come back. Okay, if I solve for x, I'm going to multiply both sides by 300, so the 300s cancel. Then I'm going to grab my calculator. So in my calculator, I'm going to do 300 tangent of 22 equals. So when I do equals, I get 121.2. Okay, but here's the thing I have to remember is remember that they measured this from 5 feet off the ground. So from this point down to this point right here is the 121.2, and then I still have to add in that extra 5 for how tall that was above. So I'm going to get 126.2 feet is how tall that building should be. All right. All right, so last one. A building is 21 meters tall and it casts a shadow. All right, so again, I have my building. Okay, and I have the ground. And it looks to me like we're going to be making some kind of right triangle going this way. All right, so here's the deal. Whenever there's a shadow, it's not floating in the air next to the building, right? You're going to see the shadow on the ground. So when they say a building is 21 meters tall, that's the vertical distance, and the shadow is on the ground at 25 meters. And they want to know the angle of elevation. So they want me to find this angle right there. So I'm going to pretend I'm standing there. I'm going to work out what trig function I should use. Looks like I have adjacent and opposite, so I'm going to use a tangent again. So I'm going to get tangent of theta this time because I don't know what the angle is, equals opposite 21 over 25. All right, and next thing I want to do is I want to get rid of the word tangent. So the way you get rid of the word tangent is we're going to use what's called an inverse. So on the other side, I'm going to write tangent with a -1, which just means inverse. That's all it means. Okay, it's not a mathematical term of 1 over tangent or anything else like that. It just means inverse. And then I keep the 21 over 25 fraction right where it is. All right, so this is the only time you ever look for this button on your calculator is when you're finding an angle. So on my calculator, right above the tangent button is an inverse tangent button. Okay, so inverse tangent, and then I'm just going to put in the fraction 21 divided by 25 equals, and I'm going to round to the nearest, hello. I'm going to round to the nearest degree. So I think that's going to be 40 degrees. Cool. All right, so there's our practice. I know there were also problems with the homework being posted correctly, so I'm going to go check on that next. Thanks for hanging in there, you guys. Have a great week. And if you have any questions, office hours tomorrow. That's Friday. And we'll see you soon. Thanks a lot.